About 2 months ago, I had an interview and I was asked how TCP works. Sounds easy, right? I always thought I knew the answer, but when I tried to explain, I realized I actually didn't. It was so embarrassing that I decided to make this video. It's not about TCP, but I want to cover all popular network protocols, including TCP. And in this video, we'll talk about TLS. We'll implement TLS version 1.2 because it's the most popular one. I'll use a TLS server from the standard library and implement the client myself. The server will be simple, just an infinite loop that accepts client's connections and reads messages. Because TLS is a cryptographic protocol, the server also needs a certificate and a private key. I don't want to go into the details of how certificates work in this video, so we'll generate one using OpenSSL. Now, let's move on to the TLS client. The first thing we need to do is to connect to the server over TCP. And now things become a bit more difficult. We need to perform the TLS handshake. It begins with the client sending client hello message. As you can see, I've already got some structures that are copied from the TLS specification. We'll discuss the fields a bit later. Now, let's write binary serialization for them. We need to serialize each field one by one. And for slices, there is a small trick. We should put the lengths in bytes before the slice itself, so the server knows how many bytes to read to get the whole slice. And about extensions. We handle them the same way as slices, but to calculate the lengths, we need a separate buffer. Every TLS message also has a header with its type and length, and both these values should be packed in 4 bytes. The first byte is for the message type, and the other 3 are for the length. And that's it for the client hello message. TLS tells us to wrap every message in a TLS record. Records help manage fragmentation, because messages can become really large, but for this video that won't be a problem. So let's just write a simple function for it. First, we tell TLS that our message is of type handshake, then specify protocol version, which is represented by these 2 bytes, and finally we write the message lengths and the actual data. You might be wondering why I use big-endian everywhere. That's because a long time ago someone decided to use this byte order for all network protocols, and now it's the standard. Alright, let's build our client hello message. The random structure includes the current Unix time and 28 random bytes. The protocol version matches what we used in the TLS record. The session ID will be empty for now. Next are cipher suites. This field tells the server what encryption algorithms we want to use. Since our OpenSSL certificate uses RSA, we need to choose a suite that supports RSA too. I'll go with this one. It's relatively new and secure. And we'll set compression methods and extensions to 0 for now. And don't forget, we need to set the same cipher suites on the server so it can find the suitable ones for the client. Now let's wrap the message in the TLS record and send it to the server, and let's also read the response. As you can see, we've got some data from the server, and it's probably server hello message, which is the second step in the TLS handshake. We'll talk about it in the next video. The code is available in the description below. Thanks for watching.